In today's learning module, we are going to discuss applying color theory to creating a perfect storm animation. We will be discussing data from Hurricane Katrina. This data is measured out as a 2-kilometer grid resolution using the Weather Research Forecast Model that meteorologists often use to understanding phenomena such as hurricanes. The animation shows rain isosurfaces with the purple areas being location of heaviest rainfall. Dark blue areas are land masses. In our color theory presentation, we will show how we built up the purple rain masses as the hurricane is evolving, and how we used orange vectors as the contrast to show the wind vector motion. We will highlight 3 topics: applying color theory to a time series animation of Hurricane Katrina, using Adobe Cooler to analyze an existing color scheme, working with Color Brewer to build the tropical storm animation color sequence. We will also present the 2 color schemes using Color Scheme Designer. Let's use Adobe Cooler to analyze the colors in our hurricane visualization first. So what we do is we take a frame of the animation, convert it to a JPEG, and move it into the Adobe Cooler tool, which is an online tool for analyzing color. We put the 5 sensors provided to us on the various colors in our JPEG, and we developed a 5-color scheme presentation. Our color scheme ranges from red, orange, purple, and blue. As we examine our color scheme presentation, we use it by looking at a color wheel. When we look at the color wheel, we see we have a complementary color scheme. That would be the orange and the blue are complementary by a straight linear relationship opposing each other on the color wheel. We also have an analogous presentation, which is the purples and the blues together. Analogous colors are in close proximity adjacent to each other on the color wheel. We also have an outlying red color. This red color comes from the animation sequence, and it comes from the mixing of purple and orange together in the animation to produce sometimes a red element that appears in the animation. Notice how the Adobe Cooler tool provides us the color values for various color spaces, such as hue saturation value, red, green, blue, cyan, magenta, yellow, and key black, CIE lab, and hex. Here I have emphasized the hex colors because those are the particular web colors that would be of interest to know of each of these particular colors we have isolated. The key elements of our color map design include establish color maps based on the flow of the animation sequences rather than static image displays. Color Brewer helps us to mock up the color displays. From the color mock-up, we transfer the final color maps into a visualization animation tool called Visit. Now note, Color Brewer is for static geographic maps. So we use this as our design principle, and our goal is to build an animation sequence that will imitate our color map. So as we look at the Color Brewer tool, which is a flash-based solution, we see that we can develop a color map based on oranges and purples. And we've selected that option. It turns out to also be colorblind safe. So if you have color deficiencies, you will still be able to see the contrasting values. Color Brew was developed by Cynthia Brewer and her team of programmers at Pennsylvania State University. Colorbrewer2.org is where you can find this tool online presently. Now we show the frame from our final animation sequence. Here in this frame, we see Hurricane Katrina as it is built up to the purple zones and the final orange zones. When we chose our color maps, we used orange for our wind vectors, we used blue for the background, ocean, and geographic regions, and we used magenta for the buildup or the hurricane. As the rain isosurface builds up in contrast with the blue background, we develop and color mix purple. This also contrasts with the orange vectors, and the contrast at times becomes so great that there's a vibrating feeling with regards to the elements shown together. Now let's use color scheme analysis to depict the two color schemes that are in our hurricane visualization. We described earlier the analogous color scheme, colors adjacent to each other on the color wheel. That becomes blue, magenta, and purple. Notice that what we have is blue on the outside, magenta on the outside. The color mixing leads to purple on the inside. We have a complementary color scheme, which is the blue land masses and the orange wind vectors. Notice these two colors are directly opposite each other on the color wheel. When we combine the two color schemes together, we get a vibrating trend that emphasizes the purple tones and the orange tones. Here we show a snapshot of our animation evolving in a nonlinear editing system. And as we look at it, we can see how the buildup of the color occurs. This is what we are trying to achieve. Now let's look at the movie, the final animated sequence. We also developed a voiceover and music to highlight the visualization. To study the colorization of our hurricane, I have removed the background music and the original voiceover of the movie, and I will discuss now with you as the hurricane builds up and how the colorization occurs. Okay, we begin to see Hurricane Katrina developing in the ocean, and we see as the color builds up, we see the purple rain isosurface developing and moving across the United States. If we look a little more carefully at this visualization, we also begin to see that we start out with a blue tone, then we build up into deeper purple tones with the orange wind vectors highlighting over top of the isosurface. There is a dynamic projection of the color as the orange tones are placed over top of the purple tones. This is what we saw when we looked at our original static color map of the visualization and how things should proceed. We are pleased to see our static color map maps very well onto our animation sequence as the color builds up over time. We therefore are applying our principles of color theory during the actual animation process. Let's look at this visualization one more time to see the buildup. Okay, we see as we go across, we see the animation build up with the purple tones. We see the contrast with the orange wind vectors overlaid over top of the animation. We also see the analogous color map with the blue taking off as well. Right now we give video credits for all of those who worked on the particular animation of this project. This is a very broad project regarding scientific visualization that include meteorologists, programmers, colorization specialists, and computational modelers. We're very pleased. We were also funded by the Department of Energy in the United States, and we received an award at their conference in 2008 for our contribution to this work. This is a terrific effort, and we're very pleased with the results of our research. We're also pleased with the color theory applications that occurred. We hope you enjoyed seeing this color mixing example. Now let's highlight where you can find more details about our hurricane perfect storm visualization and its colorization theory. In 2011, I did an article exploring our approach to colorizing the hurricane data. It was entitled Exploring Visualization Theory. It appeared in IEEE Computer Graphics and Applications magazine. Volume 31, Issue 3, pages 6 through 7. We provide the URL to accessing this article. Recently, I published a book chapter that includes the Hurricane Katrina example. This book chapter discusses applying color theory to visualization. We hope you enjoyed our brief module presentation today, and I'd like to thank many colleagues in visualization and digital media who have helped me learn so very much over the years. With much gratitude and appreciation, Theresa-Marie Rhyne. Thank you for listening to me today.